The Schubin Talks Introduction to Next Generation Imaging is presented by SVG, the Sports Video Group, advancing the creation, production, and distribution of sports content at sportsvideo.org.
Welcome to the introduction to the Schubin Next Generation Imaging video series. And Next Generation Imaging is also known as MORE, as this sign from the 2015 NAB show indicates. But more what? Well, the top four things I'm going to discuss in this introduction a little bit: stereoscopic 3D, more channels or programming, more different characteristics of sound, more wideness or aspect ratio. And the bottom four I'm going to discuss in the next three presentations: visual dynamic range, which is a form of contrast, bit depth, which is supposedly freedom from contouring, temporal resolution, frames per second, and spatial resolution or detail. And the middle one there, color gamut, or the range of colors, I'll be speaking of a little bit this time, and also a little bit in the presentation on dynamic range. So, back in 2010, next generation imaging looked like it was going to be stereoscopic 3D. And why did that not turn out to be next generation imaging, even though we saw it all over the Consumer Electronics Show, all over the National Association of Broadcasters Convention, the International Broadcasting Convention, and so on? Well, one problem was a need for glasses, which limited the number of possible viewers per TV. So if you were going to have a party to watch the Super Bowl or the World Cup or something, you needed to have glasses for everyone. And those glasses were breakable. You might accidentally sit on one. And most of them were electric, and so they needed to be recharged. And there was also a potential visual conflict between vergence, which is what our eyes point at, and accommodation, which is what our eyes focus on, and that's different between children and adults. And at the right, I'm showing a diagram from the Visual Space Perception Laboratory at University of California, Berkeley, and the dark shaded area is called Percival's Zone of Comfort. That's where it's okay to have a little mismatch between vergence and accommodation, but if you go outside that comfort zone, then you can have problems like headache or nausea. But the other MOREs don't make viewers nauseous, and that may be one reason why we're going to move in that direction instead of stereoscopically. But there are still trade-offs and issues of storytelling and issues of legacy equipment, both for production and in homes, and issue of satiety, when maybe you've had enough of more, and interactions between the different forms of MORE, and then business promotion issues. So let's take a quick look at those. Some trade-offs. Here's an image of some pipes, and you can see they're pipes of different sizes, and so they can carry different amounts. Well, for broadcast television or cable television or satellite television, we effectively have pipes. And let's take the current broadcast digital television system in the United States. It has a capacity of about 18 million bits per second. Well, that means it could carry 1 million bit per second programs, or it could carry 18 million bit per second program, or any other combination in between. So there's a trade-off there between quantity of programs and quality of those programs, quality from a technical standpoint. Then there's issues of storytelling. I put up a poster of The Hobbit here because there's been a big concern about the frame rate on The Hobbit. I'll talk about that in a moment. But in storytelling, less can sometimes be more. So the concept of 24p, that's 24 frames per second progressively scanned, won an Emmy Award. And that's actually lower frame rate, or lower images per second, than traditional television, which is either 25 frames per second or 50 images per second in Europe, or 30 frames per second and 60 images per second in the United States, sometimes 60 frames per second. When we want to show someone looking through binoculars, we tend to mess up the picture to create that kind of figure eight that you're seeing there. That's actually not what people see when they're properly looking through binoculars. They see a complete field. Similarly, with a telephone call, today's telephone calls are quite high in quality. There's really no way to tell whether you're speaking to someone across the world or next door. But if we have a telephone call in a television program or a movie, we want it to sound different. So we want it to sound something like this instead of being very clear. And so that's what the indication at the bottom right is, that telephone calls need to be filtered. But even though less can be more, different people have different ideas about what should be used for storytelling. So here's an image of the great Russian director Sergei Eisenstein, and he thought that movies shouldn't be wide, they should be square at best, and he even liked a vertical aspect ratio, something that was narrower than it was high. Here are two great French directors, Jean Renoir and Francois Truffaut, and both of those complained about color and said, movies should be black and white, they shouldn't be colored. And then here's another director. You might not be so familiar with his name, but he's talking here about how he's spoken to other directors, and they think a silent movie, a movie without sound, is the best way to go. And here's one of his creations. It's called The Artist. It was black and white, it was silent, and it won the Oscar for Best Picture of 2011, and he won as Best Director of 2011, and it earned $133 million in box office gross, which is not bad at all for a silent black and white movie. So let's get back to The Hobbit. Now, The Hobbit was released at a higher frame rate than is normal for movies. Movies are traditionally 24 frames per second, and in some theaters you could watch The Hobbit at 48 frames per second. And there were some complaints about that. Some people said that they had a queasy feeling, and maybe that had something to do with some high rotating shots and not really with the frame rate. Other people said they had a hard time with suspension of disbelief because it seemed to be too video-like. But that was a small number of viewers who had those complaints, and whatever you may think of The Hobbit, it earned more than $1 billion in box office gross. So higher frame rate is not necessarily a bad thing, just as we've found that sound and color are not necessarily bad things. Some of the other mores, there's the issue of legacy. Here you see an image of me from a little teaser that was broadcast about a show that I worked on. The bottom left image is the correct one, but the top left one is fairly common on widescreen TV sets that are getting a 4:3 signal, one that's chopped off. And then the top right one is something that you sometimes even see a postage stamp version that's both the wrong shape and the wrong size. So that's aspect ratio. There are also issues of color primaries, which I'll talk about a little bit later. Receiver decoders. You can go to a wonderful system for delivering images and sounds, but if the receiver doesn't have a decoder for it, that's a problem. Non-integer frame rates is one of the legacies that we're dealing with. So those are all things that have to be dealt with in this era of more. Then there's this issue of satiety. So let's say you go to a party and they're serving hamburger sliders and you have one hamburger slider. Might be very tasty, might be all you want at the moment, but if that's supposed to be your whole meal, you're probably going to be still hungry. But here's a good size hamburger, and that might satisfy you for a meal, and so the difference in hunger satisfaction between the slider and the hamburger is pretty significant. But what if you've had that big hamburger and then here comes this humongous hamburger that requires two hands to hold? Maybe that doesn't go beyond the other hamburger in satisfying you, or maybe it satisfies you only a little tiny bit more. So we don't necessarily have a linear progression going from something like standard definition to high definition to ultra high definition. There might be this satiety that's occurring, and I'll discuss that later in one of the other videos. Sound is another area where satiety matters, and let's talk about sound immersion. Now, in the 1970s, I participated in some focus groups where we introduced stereo sound for television, and people said that the stereo even made the picture seem bigger, so it can have a significant effect. But at the International Broadcasting Convention in 2013, a German organization, the Penguin Engineering Bureau, did some testing of sound immersion, and then they released the results the following year in a poster, and that's what I'm showing here. Now, in all cases, the majority of people felt that the version that had more channels or more dimensions was more immersive. But let's take a look at the individual bars. So let's start with that middle bar. That's one-dimensional sound versus three-dimensional sound. And you can see that a tremendous majority picked the three-dimensional sound as being more immersive, and only a little tiny minority, that's the little purplish area over at the right, thought that it was the other way around, that the one-dimensional was more immersive than the three-dimensional. And then if we go down to the bar below that, you can see that if it was a case of even one-dimensional sound versus two-dimensional sound, still a very substantial majority felt that the two-dimensional was more immersive, and only a small minority felt that the one-dimensional was more immersive. But now take a look at the top bar. This is going from two-dimensional sound to three-dimensional sound. So we've already made a significant jump from one-dimensional to two-dimensional. And now it's a much smaller majority that feels that the three-dimensional sound was more immersive, and it's a much larger minority that felt that the two-dimensional sound might even be more immersive than the three-dimensional sound. So that's kind of like the hamburger, going from a slider to a regular hamburger. That's a substantial improvement, but going from the regular hamburger to the humongous hamburger, that might not really satisfy your hunger any more than the regular hamburger did. And I'll also point out down at the bottom there that there are other possible mores in sound, such as more frequency response or more dynamic range, but we've done pretty well in the digital era with both of those, so that's another uphill battle. Now, perception is not inherent, it's something that's learned. So kittens that are deprived of a stimulus can't perceive that type of stimulus until it's learned. So they've done this experiment where they have pieces of glass and they have lines on them, and the kittens are encouraged to walk across the piece of glass, which is very clean, so it looks like it's not there. And if they deprive some kittens of, let's say, horizontal lines from birth, so they're in an environment only where they can see vertical lines, then they will walk across the glass that has vertical lines on it, but they won't walk across the glass that has horizontal lines on it because they haven't learned to see horizontal lines. Thomas Edison did some tests that showed that humans also have learned perception. He showed a new phonograph recording system starting in 1916, and he did what were called tone tests with it, where he would have a live singer and he would have a phonograph, and as the image on the right shows, he touted that no one could tell the difference between the phonograph record and the live singer. Now today we go, that's ridiculous. This is a 78 RPM mechanical phonograph recording with a needle in a groove. How could anyone possibly not tell the difference between that and the singer? Well, people hadn't yet learned how to perceive that difference. Today we have learned it, and that's why we find it ridiculous. Other more issues, there's interactions. So here is the top of a chart that appears in the third edition of the American Cinematographer Manual, and it's about recommended panning speeds for panning through a 90-degree scene. And this is from the third edition in 1969. And here's another version of that chart, and it lists the panning speeds in degrees per second. Well, since there's a certain number of pixels across a screen, and the screen occupies a certain area, like 30 degrees of visual field, then we could also talk about pixels per second. And if we do talk about pixels per second, then it becomes clear that if you have more pixels per frame, then you need more frames per second to have the same number of pixels per second. So this little chart that I'm showing here shows that if you had, say, 720 line HD TV and you have 120 frames per second, then you could pan from one side of the screen to the other in less than 11 seconds, 10.7 seconds. But if you had what's called 4K, and I'll define that in one of the other videos, and only 24 frames per second, then it takes you almost 3 minutes to pan across the frame and have the same kind of results that you would have with those 720p at 120 frames per second. Here's another interaction between dynamic range and frame rate. Now, this is a chart that appeared in an article in the Journal of the Society for Information Display, and it was originally about stereoscopic presentation, but it's still important for our purposes, even ignoring the 3D aspect. The horizontal axis is temporal frequency or frame rate. The vertical axis is spatial frequency, which is shown in cycles per degree, but it could also be pixels across the screen. And the black circle is what's visible. And I've added a red oval, and that shows what's desired. Now, what's desired is just that diagonal line in the center. But you'll see that there are many other lines, and some of them are visible inside that black circle, and those produce what are referred to as motion aliases, or things that you're not really supposed to see, but you're seeing. But notice that the lines are not of equal density. Some of them are very black, and some of them fade away, and some disappear altogether. Well, the ones that have faded away or have disappeared aren't introducing a motion artifact, or are introducing just a really reduced motion artifact. But if you increase the dynamic range, then you make that motion artifact more visible. And some of you who may have seen some high dynamic range demonstrations may have noticed that the motion judder, or the motion artifacts, seem to be much worse in the high dynamic range version than they are in the standard dynamic range. So another interaction that we have to deal with. Sharpness also is based on two different characteristics, not just resolution, but both resolution and contrast. It's proportional either to the square of the area under the curve that I'm showing here, or some people say it's just the area. But either way, whether it's the square or the area, it's significant that contrast adds to sharpness as well as resolution adding to sharpness. And then finally, we have this issue of business promotion. Let's talk a little bit about wide color gamut for that. This is the visible colors that we can perceive, and this is only for a certain brightness level. There are different curves for different brightness levels. And here's a hypothetical ideal 3 primary display, or an image display that has 3 colors, which is what almost all image displays use today. And we're making the red as it can possibly be, and we're making the blue as it can possibly be, and we're giving a green that might be the greenest that it can possibly be. But because there's only 3, we're still losing a significant range of the blue-greens on the left, the turquoises, if you will. So there's a company called Genoa Color Technologies, and they say, well, one way that we can recover some of that lost information is by going to more than 3 primaries. So they say we can go to 4, 5, or even 6 primaries. Now, one issue with that is it does take up room on the display to add those additional primaries, and so that has an effect on resolution, another interaction. But what I'd like to point out in this case is how accurate the colors look. So here you see on the upper left a camera that's shooting some material, and there's that kind of pinkish purplish stuff on the far left, and then we have the 2 displays on the left, and you're seeing that one is not reproducing that color correctly at all. It's kind of a red instead of that pinkish purplish, and the other one is correctly reproducing the color, and so hooray, they have demonstrated that their display works better. But what's odd about this is that they're talking about these more than 3 primary displays, and yet you're looking at this picture on a 3 primary display, and you're seeing that difference. So caveat emptor. A little bit more about color. Here's incorrect color decoding. There are different equations for how the brightness relates to color, and Rec 601 is a sort of standard definition equation, and Rec 709 is a high definition equation, and you can see by the color bars in the middle there that if you decode incorrectly, well, you can very clearly see that there's a difference in the green and the cyan and the yellow and the magenta and the red. Even the blue has a visible difference there. But if you look at the actual images down at the bottom, which are more real-world images, the one in the center is what it's supposed to look like. The one on the left is incorrectly decoded in one direction, and the one on the right is incorrectly decoded in the other direction. And even being able to see all 3 images at the same time, you're kind of hard-pressed to say that one is wrong or another is wrong. It's only when we have colors in contrast, as we do in the color bars there, where we have one version on the top and another version on the bottom, that we can see the color change. So, still to come in the other videos, I will be talking much more about higher frame rate. I'll be talking much more about higher dynamic range and explaining why it's not the same as bit depth. And I'll be talking about higher spatial resolution, and I hope you'll join me for those videos as well. Thanks for watching this one, and please enjoy the others.